I'm always partial to having a small group rather than a large group. And I was thinking as I was sitting there that when I was a young faculty member at MIT once, I offered a new course, and it was scheduled for one of these raked classrooms, with seats all up and down. And I went there 10 minutes early, and I waited, and no students appeared for this course. It was 5 minutes after the time the course was to be scheduled, and one of my faculty colleagues wandered in, and he said, "My course is scheduled here as well." So there were two of us, and no takers. So in any case, it'll be good to be able to have a discussion here tonight. I'm going to do it with the help of slides. I'm not going to try to summarize everything that's in the book. There's lots there, and what I want to do though is focus on a very particular subject that I became very interested in in the course of putting the book together. And I'll say a bit about the book and what its origins are and how I thought about putting it together. But the subject I'm going to come down on is the question of localizing infrastructure. What's happened, I think, in the world is that new technologies have emerged and new green technologies have emerged that allow things that in the past have been reliant on large public systems, like water systems, sewer systems, and other such things, to be able to be done locally. And that changes the whole ballgame. It changes the whole ballgame for development. It also creates new kinds of opportunities. And so I'm going to focus on that as the main topic. But let me begin with a few things. Actually, the idea of writing textbooks about site planning goes way back, at least a century ago. They were the first textbooks done on site planning. Charles Mulford Robinson, who was the first professor of civic design in the United States at the University of Illinois, wrote a book called The Width and Arrangement of Streets, a Study in Planning, in which he kind of cataloged what it took to plan streets. Longstreth Thompson did the first book that was called Site Planning Practice in 1923. And as Carol said, my late colleague, Kevin Lynch, wrote a version of site planning in which he pulled together the notes that he'd been using in his teaching and some notes from some engineer friends who had helped him on engineering aspects, and some ideas that also came from Hideo Sasaki, a landscape architect who was teaching a similar course. So he published the first, what we now think of as site planning book in 1960, a new edition in 71, 1984, I joined him, and we did an expanded edition of it and rewrote it. And that book has been in print and used to this day. It's way out of date. I wouldn't use it, of course, but people do, and it's still going. On the right is a Chinese edition of the book. There are actually 6 Chinese editions of the book, at least. I've counted 6. 2 of them were authorized, 4 of them are not authorized. But whenever I go to China, somebody brings up one of these books and asks me to sign it, and I'm always curious about which edition they're actually using. So I begin with the premise that cities are built site by site. Planning is really important. I'm a planner. I've spent quite a bit of my life doing that. But actually, the real decisions are made site by site in the city. Sometimes they're very large sites in which you create a context for individual buildings, but often they're small sites. And so the opportunities that are realized are as much a product of how creatively people approach the individual sites as they are about any plans or grant schemes that the local government or others have created. And so what's it makes for a great site? It's sustainable to start with. It's efficient. And I'll talk a bit about what I mean by that. It's responsive to humans. It's economic. Sites are there principally as instruments to make money for people who own sites or to deploy resources well, as in the case of institutions, so that they're not wasting money on things that they could otherwise be more economical on. Good sites are compatible with surroundings, and good sites are adaptable over time. In fact, it seems to me that one of the important responsibilities of a person doing site planning is to think about what the next generation of use of that site will be, and to structure it in ways that you can actually make a transition to new uses 5, 10, 20, 25 years afterwards. Now, there are a lot of activities. Some of these are familiar to you in your various professional roles, ranging from site analysis to programming to site design to the engineering, landscape architecture, landscape design, financial planning, etc. Remarkably, this is a field that is not occupied by one profession. It's occupied by several professions. So the architecture exam for licensing architects has an examination on site planning. The landscape architecture exam has a whole section of its examination on site planning. The planning exam, which I helped write, partly because I pushed this, has a whole section on site planning as part of that kind of stuff. And so this is really a shared endeavor of a number of professions, and it has to be thought of as one where professions pool their skills, pool their resources, pool their knowledge in order to make decent decisions about how a site should be developed. In organizing the book, I decided to do something quite different from what I had done before. What I realized was that things change very quickly in some fields and not at all in others. And in the past, what we had done was written fairly long chapters, and when things became obsolete, you had to rewrite the whole book. I think 10 or 15 years from now, most publications are going to be digital. And in fact, there are 2 digital editions of this already available now. With digital editions, it allows you to actually revise pieces of it whenever you want. You can, 3 years from now, when new developments occur in a particular field, you can rewrite that chapter and you can do it. So what I have is in the book is 40 chapters, each of which is a discrete subject, and each of which is the state of knowledge today, and which is intended to be updated as knowledge evolves in these fields. So what do I mean by sustainability? I'm going to focus on that. In terms of sites, these are the kinds of things that are usually included in the business of making sustainable sites. Absorbing and reusing runoff, reducing commuting travel by cars, treating wastewater locally, reusing water, shift to shared and electric vehicles, etc. You see the list across here. There are many more, of course, things to be done. But if one can optimize all of these kinds of things on a site, then in fact the result is really a much more sustainable site. So scale also matters, and what you can do depends a little on, not a little, a lot on the scale of the land that you're dealing with. I told Carol that she deals with skyscrapers and I deal with ground scrapers, both literally and figuratively. When you're scraping a lot of ground, you have many potentials that you can bring into play. When you're scraping very little ground, then you're dealing with vertical infrastructure on it. And so here are 3 examples. The first is to a block from here. It's the Visionaire site. It's 7/10 of an acre in size. It has 250 housing units, and on the ground floor has the maintenance facilities for Battery Park City Parks. It has a supermarket, has lobbies, and a few other kinds of things on the ground floor. Second example is a place called Bed Zed, which is in Sussex, just outside of London. It's a very innovative housing project on 3.5 acres, 100 housing units plus 2,500 square meters of workspace. It's a live-work community that's been created. Now that's something you can do at that scale when enough room to spread out and do it. And the third is a much larger development. It's in Stockholm, Sweden, Hammarby Sjöstad. I think the best new community development in the world. It's been done over the last 10 or 15 years. It's been done by the city of, planned by the city of Stockholm, developed by many design architects and many designers. And it has about 11,000 housing units and over 10,000 jobs, all integrated within that development. So let me say a little bit about each of these. So in the Visionaire project, this was a real push on the part of the developers and the architects who did this project. Not only did they do things like harvesting sunlight and making energy, creating energy from it, but one of the really innovative things is they actually created a sewage treatment plant right on site. So that piece actually functions within that vertical infrastructure that they have. Water from toilets and all the other domestic uses goes into it. It's treated. It's treated to the sludge is taken and hauled to the sewage treatment plant. The water is either recycled for gray water in the building or treated again in order to make it, in fact, good enough for potable uses, although they haven't been using it. They don't advertise it when they're renting the building on it. But so there's an interesting case. There's a localizing of some infrastructure that would otherwise have occurred at the scale of a piece of the city, or at least large public systems would be the way that you went about that. It also captures and stores all rainwater on the site, uses it for irrigation of their garden on the rooftop and elsewhere on it. And one of the dilemmas that poses, which is an interesting one to me, is that they are paying for the sewers in the city at the same time that they're localizing them and doing that job in the building. And so there's been a long dispute about whether they should get credit for not using those kind of public systems. What's clear is that when you begin to localize, you in fact have to now think about, how do you give people adequate credit for the investments that they're making in these kinds of elements. Here is the BedZ project, a kind of remarkable project. It looks crazy when you see it, but it's a project that's been, its major objective was to have zero net energy used in this project. That is to say, they are not adding to the either external requirements for energy or are not also putting into the atmosphere any additional carbon as a result of the development. So how do they do it? Well, one way they do it is that they orient the building so that they get passive sunlight for a good deal of the heating demand. They have, sorry, let me go back on this. They have solar panels that are used to generate electricity, mainly for charging the electric cars, which are the only vehicles that are allowed on the site. They have a live-work arrangement where buildings, behind this one, for example, there is a work building connected directly to the apartments and houses on the other side of it, where fairly substantial, out of the 100 housing units, there are 50 live-work spaces in this, so up to half of the units can actually live and work in the same place that's there. They also created a micro-utility, and that's this piece here. The micro-utility creates all the heating and they don't have cooling, but the heating required for the site, and in the course of doing that, generates electricity as well through burning through a chip system. So what they have done is they use wood from a wood lot that they purchased not too far from there, and they cut the wood, bring it in, burn it, and it's a renewable source. The wood lots constantly building new energy. They also use solar panels and other kinds of ways to supplement that energy. So at that scale, you can talk about micro-utilities, which in fact can in fact serve more than one area. And so these, I won't go through these systems in detail, but they're really carefully worked out in terms of, they have also, they treat all the sewage and reuse all of it in greywater, and these are some of the treatment facilities that they use. They have larger ones as well. As I said, electric cars and so on. And this is the system that they use for generating the electricity. Now, at a much larger scale, such as Hammarby, you can do a lot more. They have in this. This is a kind of wonderful development. You can see the form of it. It's mostly low-rise units. It's a complete mixed-use development with all of the institutions and all of the commercial uses that are needed. It was built at the same time that it was being built. A light rail system was connected to there to take people to the mass transit system in Stockholm, so that people could avoid actually buying a car or using a car in this. They have wonderful mass transit throughout this thing. They treat all runoff on the site. They have, and I'll show in a moment, a vacuum garbage collection system and recycle all of the materials that they collect through the vacuum garbage system. And so now we have something that begins to resemble a kind of independent operating entity that doesn't need ties to the big systems, except transit ultimately, and a few other things like that. And so all of runoff is, as you can see here, treated and reused. There were a number of, this was a brownfield site. They harvest methane gas from the brownfield, use it for fueling the heating systems, the district heating system on the site. And the idea which they have is of closed loops. Three kinds of closed loops: one on energy, one on water, and one on waste. And in each case, every piece of material that arrives in a building gets recycled, reused, and advantages the development in terms of either energy that it's creating, sales of those items, or other kinds of things. Similarly with water, similarly with the energy sector. Their mass transit is the main way that one gets around. There isn't really a need to have a car. Wonderfully innovative transit stations which have buses as well as light rail vehicles going through them. These are two dimensions of the vacuum sewage system. Roosevelt Island has a vacuum sewage system which was done in 1960. It was one of the earliest ones in the world on it, and is now kind of obsolete. What these do is they allow you to segregate the uses at the source, and then they either by suction pulling them out of areas in the ground where things are stored from places like this, or through direct suction from the individual buildings, take it to the transfer station, at which point these things are separated. Some become energy, some become compost, some become recyclable products. And so that's possible, all at the scale of a large community. And in fact, it's interesting. I looked for American examples of this, and there is no example in the United States that's begun to try to press infrastructure to this extent and try to be as innovative as they have been there. So let's look at some smaller examples of interesting infrastructure, localized infrastructure. This happens to be in Vancouver, British Columbia. It's a curious little building that sits underneath an expressway. It's a district heating plant that's been built for the Southwest Falls Creek area, which began as, part of it began as the Olympic Village on it. And so this provides all of the heat and cooling that's necessary for several thousand apartment buildings now, plus other kinds of uses. And so how do they do it? Well, first of all, it's located, as you can see, at the edge of the development. This is a sketch of or an aerial of some of that housing in the area. This is the area that it serves. It's a pretty large area on it. So how do they do it? What they do is they harvest the heat from the sewer system. They, with the heat pumps, harvest, the temperature differential in the sewage system from the outdoor temperature. So when you go and have a shower, somebody has paid energy to heat that water up to it's tolerable to you, goes down the drain and disappears forever, all that energy. So what they're doing is actually taking the 70 degree or 72 degree water and absorbing the energy that's in that in order to heat the buildings, and they pipe them back into the buildings, or in order to cool the buildings in the summer. And literally, the entire heating demand is picked up by this. They do have a backup natural gas system because they're not sure if they're going to be able to do it completely. But in fact, it seems to me this is a localization of a really important little system. There it sits, and there's the housing that's there. This is, of course, when you don't need mechanical penthouses on buildings, then you can really use the roofs for active uses, and they have done so there. And they've also treat all of their storm runoff in natural areas that are on the site. This one happened to have an extraordinary amount of algae in it when I was there, and so this is not trivial in terms of how you manage these kinds of natural systems that are there. Second example, this is a wonderful example from the Netherlands. This is a development which has about 600 housing units in it, which was planned by a group of people, many of whom were at the Technical University of Delft. And they decided what they wanted to do is create a sustainable community, and they planned it. And many of them moved in and lived there, and many of them, a number of others joined in, and it's continuing to expand, so it got much larger. So the site for this was a curious site. It was the city's water tank and all of the wells that provided drinking water for the city. And so what they did was they decided to keep all that in place and to use that for heating, much as they did in the Vancouver example that I showed you, and also to make water the kind of central theme of their community. So this is the layout of it. It's a wonderful. It's called Lanksmeer. It's a couple of railway stations from Utrecht, and the houses range from clusters. Whoops, I'm sorry. Clusters like these kind of clusters, each of which is its own distinctive character in which people manage the common space collectively. No cars are allowed in the development. You park your car out at the edge of the development and walk from there. And the railway station is over here, and so if you're living here, you can walk as easily to the railway station and take it to other places on it. There are also lots of really wonderfully curious individual houses, and this happens to be a Montessori school that they've created in this. But the whole thing that draws it together is essentially water, and that water begins often with harvesting the water from rainwater, storing it in cisterns, using it, then discharging it into wetlands areas, wetlands that are also used to irrigate orchards and grow food and other kinds of things as part of the community. And ultimately, it's actually improved to drinking water quality, and this little beach that they've created is that same water that came from both the sewage of the community and also the runoff going through the community. Here's a third example. This one actually surprised me quite a lot. There is a project in Portland, Oregon called Hassalo on 8th. And it consists of a 4-block area in which they treat all the sewage out on the street. You think that these examples, like I showed, the Dutch example I showed, are only applicable to low-density areas. Well, this is a pretty high-density area. These are the 4 blocks that it's treated. The street in between, you can see, is this one, and all of the water. A couple of them are residential sites, a couple of them are office sites. All of the water is treated both by flowing through a series of treatment cells out in the open, and also through purification devices, including some filtration devices over here. So how does that work? Well, I won't go into detail, but basically you have to filter water to get the big impurities out. You have to take the sludge and dispose of it in other ways. And then what they have is a series of cells in the street that the water moves through, at the end of which it's a quality that you can use for, it's also disinfected, and it's good quality you can use for irrigating that area, used for gray water, toilets, and other kinds of uses within the buildings, etc. All of this in a dense urban environment. So there's the filtration devices. Here's a view of the water moving its way through the various cells for treatment along the way. So let me turn to another piece of infrastructure that I think is crying for innovation. And that's the mobility systems that we have in our cities. There are only a few examples of places that have actually done anything about this, but this illustration, which I think is a pretty interesting one if you look at it in detail, says several things. First of all, there are going to be many more modes of mobility available. Second, it doesn't show very much here, but there's going to be increased competition for the curbs in our cities. Not just competition of Uber drivers waiting to pick up people, but parcel deliveries that are having to deliver, and the competition for the curb is going to be the big issue in streets in our cities. There are also going to be many more local mobility systems. Cars that you can rent by the hour to move around urban areas, or go from a transit station to a more remote place, or if you're carrying something, etc. Scooters, motorized scooters, which are already taking over the streets in Baltimore and in other places. There, of course, are bicycles, not only the ones moored to bicycle rental stands, but also the free bicycles that you can leave anywhere, the cars that you can rent and leave anywhere, and so on. And all of this suggests that there is a kind of local planning that needs to get done around the issue of mobility. Now, I say local because actually when you look at the distribution of trips in most cities, most trips are local, short, from one nearby place to another nearby place. And solving that kind of mobility problem is going to become a major driver. So what do we have? We have all of these kinds of things in Paris already, electric rental cars. It seems clear that a large fraction of the population doesn't want to buy automobiles, they want to rent them, use them when needed. Mobility when on demand, as in the case of Uber. But all of these things as well. And I don't think we're prepared for this in terms of our streets, in terms of the way people use our urban areas. A few people have done some thinking about this, and the downside of it is that we could actually be just overwhelmed by the number of vehicles that are crowding their way onto city streets with no discernible order for them. This will also have a big impact on parking. My colleague at MIT, Carlo Ratti, thinks that you could reduce a minimum of 30% of the number of parking spaces in cities, and probably up to as much as 70% of the parking spaces in cities, depending on what the break is in terms of people renting and sharing vehicles versus buying their own vehicles. But under any circumstance, you're not going to have to park your car in the future. You're going to drive to the entrance of the garage, and it'll self-park, and it'll come on call afterwards. And so other cities have already begun to respond in various ways. This wonderful parking garage in Miami Beach, which serves as an event space when it's not used for parking. Terrific idea. Vertical parking systems like the one in the middle. And it also means that when we think about parking and that piece of infrastructure in a city, we have to think differently, because sloped parking garages don't work. And what you want is big parking areas where you can pack many cars in, and they'll automatically shuffle themselves to get out of that garage. So then the other big elephant in the room, especially here in New York today, is Amazon and the entire shift of what's happening to the retail sector. And of course, it's everything, anytime, right away. And that has meant and will mean continuing crowding of the streets with vehicles that are devoted to delivering those things. This is a student center at Tongji University in Shanghai, and not only has their online ordering wiped out the local bookstore, because nobody goes there for books anymore, they just order them all, but most of the students get most of what they need this way over here, and we don't have any way to think about what to do about that. We need to deliver them. We need to make logistics spaces where things can be shifted from big vehicles to small vehicles. Ultimately, drones will have to be accommodated. And so where do we put the stuff when it arrives? There are places now creating parcel motels where you can have your stuff delivered and pick it up later. There will be automated delivery vehicles arriving at front doors and waiting there for people to pick up those parcels or whatever they're receiving on it. Another demand on the curb. Now, Björk Engels did a very nice little study a few years ago that's not widely known. And it's a study that said, how would you change streets if you understand all of these autonomous vehicles and other kinds of things are going to be using the streets, and that they're going to have the capacity to avoid collisions, avoid pedestrians, and other such things. His argument was that we should now begin to think of streets not as channels, as we have for so many years, but as a plastic space that's capable of being changed constantly. No curbs. The entire front to front of streets being thought of as a place where all of these activities can occur and can be scheduled at different times of the day and the night. And he even argued the Potsdamer Platz in Berlin, in the evenings when there's less traffic than in the daytime, you could hold a concert in the center of that Potsdamer Platz, and people could wander across and ride their bicycle over there. Cars would avoid them and find ways around and through that maze on it. Well, that may be, a bridge too far. The reality is that, in fact, we're going to have to rethink our streets, because with all of the new vehicles and all of the new uses, the allocations that we've had in the past are not going to be appropriate. In addition, a substantial amount of street space is going to be freed up. It's going to be made available for other kinds of uses, and streets are going to look differently, as you see on the right hand side. We also may have the capacity, as the numbers increase of things like bicycles and their use increases for longer distances, to begin thinking about the creation of bicycle freeways and other kinds of things which segregate those uses from the more local kinds of uses that are occurring on the street level. Finally, I want to conclude with a little bit about the underground. In the past, in doing site planning, here's what we thought about. Where do you place the sewer lines? Where do you place the electric lines, et cetera, within the street right away to protect them, to make them available for repair, et cetera. And of course, what's happened over time is that streets have become this kind of phenomenon. The underground has become this kind of phenomenon. And whenever an earthquake occurs, or a sinkhole, as this one on Fifth Avenue occurs, or what you have to do is disrupt all of the other uses on the street. And it occurred to me as I was putting this stuff together that thinking about the organization of the underground is going to be a really critical piece of the new infrastructure that we're going to need in cities. And so instead of having to take this street and tear it up periodically for new kinds of cables and fiber optics and other kinds of things, many places, particularly large institutions, are building underground utility corridors, an underground street system that allows them to service many utilities within that without having to disrupt the life on the street. In fact, Singapore, which is usually ahead of the game in almost everything, has begun to rationalize where things occur vertically underground. And so, as you can see on this thing, they have established different levels for transit, different levels for the underground utilities and walkways, as you can see on this one here. Sewage and power grid, or another container on this stuff in here, and very deep into the ground is the major electric cables that serve it from the generating stations. And beginning to rationalize this is going to be an important piece of what we do. And it was interesting to me that in the first several decades of this century, Chicago had an underground railway. And that underground railway was intended and used to deliver materials to all the manufacturing buildings that were above, to take coal and other fuels that they needed in order to heat the city, the loop on it. And it operated for 30 or 40 years. And here you see the tunnels. Tunnels still exist. In fact, a few years ago, when they had big flooding in Chicago, those tunnels flooded, and that was a really serious issue. It was abandoned in the 1930s and 1940s when trucks became the major mode by which you delivered stuff to buildings, and people didn't want to have to break their bulk into other kinds of uses. But new cities like Masdar in the United Arab Emirates, in Abu Dhabi, are actually creating whole levels that are devoted to infrastructure. And I think these days it's kind of irresponsible not to build modern infrastructure into a very large, high-density development. And you can see here the various places that have been allocated within that underground level for other uses, including local circulation, which occurs in that underground level, as it does here. And these are in place. These are working. These are not pies in the sky. And finally, I think this is the final illustration. Norman Foster has done some work with Elon Musk on his system of tubes. And this is a far more ambitious infrastructure idea. But the argument which they are making is that why do we unload stuff in a port, then put it on a truck, and then take it to a warehouse, and then take it out of the warehouse and take it to the final destination, or something that resemble a final destination? Why do we have all these steps? Musk has argued that one could develop a set of pressure-free tubes which could easily move containers of various kinds from the port directly to the destination. And so what you see here is the port landing, loading, traveling, these tubes traveling to the city, arriving, being unloaded, and then taken directly into their destination. When we were working on the World Trade Center, it occurred to me that it was sort of silly to imagine that you would take trucks throughout this entire complex down below ground and spend the amount of money that they did for doing security checks and other kinds of things right there. It seemed much more viable to create a processing facility somewhere nearby and then put things in containers and take them into individual buildings and up the elevators into individual floors. That's how we work airports. We don't bring the trucks out onto the landing areas. That's how we do other kinds of mass infrastructure. And I think the business of materials handling is going to become an important piece in the future. So I end with this slide, and I do it for a couple of reasons. First of all, localizing infrastructure doesn't solve other kinds of problems. It doesn't solve the problem of flooding, which happened after Hurricane Sandy in all of lower Manhattan. But, you know, Battery Park City has energy. And it
except our building, which is dark, because you're right there.
This is down there.
Transformers were in
That's
it.
right.
With salt water.
It has, for most of the development, though, is actually above flood level. And it continued to function as a result of that, because of the localized infrastructure that was in place. And so I would say, what if they had another infrastructure system here, and another one over here, and another one over in here, and built towards that, so that they were less dependent on the large public systems and the disruption that might be caused by major catastrophes like the hurricane. Let me stop there. Your thoughts, your comments, your contributions to this. I know some of you have done large-scale developments and are doing them, and it would be great to hear your thoughts on this.
Here's my question is what you were saying about scales, and you're demonstrating that these strategies can be used at different scales. Is there a scale at which they're most efficient, or does efficiency operate equally on every scale?
Well, certainly things like district heating are better done at a larger scale than a smaller scale. That's just simply the efficiencies of being able to generate heat on it and co-generate electricity and other kinds of things like that. You wouldn't put you don't need a district heating system in the Visionaire. You have its own heating system in that place, and it's hard for them to generate enough energy from alternate sources than probably natural gas, which they use, to be able to do it. So, that goes into play at somewhere larger, but that development in Sussex has only 100 housing units, and the Visionaire has 230 housing units. So it's it's not impossible to imagine it.
It's get more complicated at larger scale.
Yeah. Yes.
Okay, so I got a lot of stuff. I just wanted to ask you about the Amazon thing. With Amazon moving here, announcing that they're going to employ 25 and set aside an area in Long Island City and blah, blah, blah. Are they going to come to people like you and say, help us plan this thing, and how are we going to do all
Not
of this?
necessarily me, but I hope they go to planners and ask them to think out of the box. I mean, they have done that in Seattle in their buildings that they created. And,
so then what about looking at that to an area like Hudson Yards, for example? Larry Silverstein said that Hudson Yards is a waste. They got one train, there's 7 that goes there. We got 18 trains, forget about it, everybody's going to still be coming here. Wasn't there more site planning at the time to say, hey, we need other things, means of transportation and stuff to make this viable?
Well, I think that first one was probably demand for both of them in the city. It's not a question of either one or the other. They may go a little more slowly because there are two of them going, but there are some things that were done at Hudson Yards to try to make it more sustainable. I mean, from individual building elements that have been included in it, but also including the work possibilities in it, and the kind of mix of office space that's probably going to evolve over time that will have small businesses as well as large businesses and give more opportunities for people for starting things and other things like that on it. I don't think that there are some underground areas that are devoted to utilities, although they have a problem with rail tracks below them that limits what you can do. But I would have thought actually that they would have devoted some of the underground to common utility areas that serve the entire site and which were easily accessible, easily changeable, etc. I don't think they've done it. I don't know, others may know the answer to that.
Do you envision a proliferation of wind farms to address some of these issues?
Well, I think wind's a possibility, and they have a couple of them at that Dutch project that I showed you, and wind can be done at a fairly small scale too. There's a wonderful development which I cover in the site here, which is the Methods manufacturing company that does method cleaning goods and other things like that. Built a new plant in Pullman, Illinois, and they serve a large fraction of their energy from a single windmill that they have above that. They also use solar panels, they use a whole series of other things. It's a fairly sizable plant, but at that scale you can actually make those kinds of things work.
When you were throughout your experience and all these interesting examples, have you thought about studying examples in the global south where resources are more scarce and many cities are much more sustainable than our cities?
Yes.
And there's not a need of cooling and heating as much as we need it. As examples to take, because all these infrastructure layers that you think that we need to keep the space for are also infrastructure that we might not need, or we should revise if we really need them. So that's my question.
Well, I have looked at a little bit in the global south. I did some work in Bogota, and Bogota has wrestled with the question of how to create modern infrastructure in their city on it. But these kinds of issues, I mean, everybody in the global south wants internet service, and everybody wants good transit service, and the issues are not as different as one would think. And, the resources to produce them probably push more often towards natural solutions rather than technology and gray technologies on it. But each place has to find its own accommodation.
So I'm sitting here when you started thinking, oh good, we're going to look at something that happened in the US, all kinds of great examples, and then you said there aren't all kinds of great examples. And then I'm thinking back to redevelopment projects that we've worked on in Europe and the US, and in Europe they make us come up with sustainable ideas for new projects. Here they don't. What is your, what do you owe that to? What do you think that is making that happen?
Well, we've underinvested in infrastructure in the United States for a long time. We've gotten in the habit of minimizing the amount of public outlays that are required in order to support developments, and that means that stuff becomes obsolete, and you pay for it year after year by digging up streets and doing other kinds of things like that. I'm worried that we're going to not invest in rethinking streets now with the new mobility that's available for us, and then we'll be playing catch up again on that. There are streets in China that places in China where they're actually now working on trying to make themselves accessible by the new elements of mobility that are available to them. And we tend to play catch up, and partly because, in fact, in European cities, for example, in that Stockholm example, I mean, that was public land they were dealing with, and so the public could set the agenda for it. And interestingly, it was designed with, much as Battery Park City was, with individual parcels, design guidelines for the parcels and individual developers of every one of them. And there are lined up about 10 different developments that are basically the same size, same scale, where private developers competed for the most, the most sustainable, the most efficient unit that they could design along that. And so more public direction of development, in fact, is one reason there's a difference on it.
I wanted to ask you, what do you think about city planning in China that used to be so, or still is very heavily, that relies very heavily on the use of cars, maybe copying the American system from the 20th century? We just copy how it was. Do you think they're going to have a big problem in the future, or they're going to solve it, or with this new mobility transportation that you were talking about?
So I spoke in China about a month and a half ago about this issue, and I asked the audience, a very big audience of architects and planners and others, do any of you believe that the kind of cars we're driving on the roads today are going to be the cars we're going to be driving 10 years from now? Nobody put their hands up. And I said, well, if that's the case, why are we designing roadways for those cars that are not going to be used on the roads? The roadways are going to last longer than those cars. And I think it's beginning to, in some cities, dawn on them that they have laid out, way too much land for roadways. And now they're beginning to think about what could we do with some of that space that's along those roadways. What other kinds of uses could we put? Could we put parks along them? Could we put commercial uses, which are sadly lacking in so many areas of the city, and so on. And it takes a while because the hegemony of traffic engineers and other kinds of people in the planning process has been quite solid.
I used to work in China, where I was asking, in an urban design department, and one of the in one of the meetings with city officials, we were proposing a project with narrower roads, and they got very upset because they wanted very wide roads.
Yeah. Having said that, some of the best developments in China are in fact places where they've tamed the roadways. The Xinjiang project in Shanghai, people love because it's scaled to pedestrians. In Shanghai, they've got a wonderful knowledge and innovation community, which has real streets and sidewalk cafes along it, and also has parks along the way, etc., and only 2 lanes of roadway in between. So they're beginning to discover, that there is a different way of building cities than the way that they practiced for a couple decades.
Maybe on the China theme for a moment. I'm from Toronto, and my company had a visit this past week from a couple of gentlemen from a very large construction company in China, and they were in Toronto to talk about or find out about the sidewalk Google project, which is supposed to bring that next level of development and autonomous vehicles and so on. The interesting thing to me was that it's a giant construction company, but they've been building so much in China, they're now looking for what's next. And their purpose was to find out as much as possible about what the next future city would be, and they've got the money to build it. They're going to build a whole new city somewhere in China, and it will have autonomous vehicles and all these sustainable ideas. They're going to do it, and I believe they will.
Yeah, they do it in China.
Yeah, incredible.
Yeah.
Yes, a lot of this is, I love that you showed some actual practical things, but a lot of it's still visionary, right? In terms of, and there's still issues about electrification versus burning, even wood products are going to put carbon into the atmosphere and smoke and stuff. So how do you think about, how does one think about what we can do today and probably in this country, maybe it's part of the answer for, it's more about economics than other countries who are thinking that there's more government involvement, thinking more about the future. But how do we do today what makes it's going to make sense 20 years or 50 years from now? So.
You know, we haven't tried to juggle the incentives in a way that make it possible to invest in these kind of technologies locally. When a developer takes on a parcel of land, they have to pay, in most communities, for the off-site infrastructure that they haven't built. And even if they wanted to build, an on-site sewage treatment plant, they'd have to pay for the off-site piece of it. And so part of it is rethinking the incentives that we create. Philadelphia did a very interesting thing. They had a choice of building a $7 billion new storm sewer system and treatment plant. And they decided that they would not do that. What they would do is spend $3 billion on water management of various kinds. So what did that mean? One thing they did, a very simple thing, which is that when you buy water in most cities, you pay for the sewage to take it away. So if you have a parking lot and you put water into the sewers, you don't pay anything for that sewage. You put it down. And so what the city did was a very simple thing. It split the bill. You pay so much for the water that you use, so much for the water you put into the sewer system, the waste you put into the sewer system. So if you want to take that parking lot, leave it there, you pay for it. If you want to make it into a sustainable parking lot, which absorbs most of the runoff and puts it into the groundwater and uses it for irrigating plants within the parking lot, you may pay nothing for that. Similarly with a building, if you want to treat the waste as they do here, you don't pay for the sewage part of it. And so, by pricing things right, you can actually have people behave in different kinds of ways. Actually, if you want to see a really interesting analysis of what kind of a difference this makes, there have been a couple of really good analytical studies of the BedZ development. You can get them on the internet. And what they have looked at is what would a comparable development without all of those features consume in terms of energy, in terms of water, in terms of travel times, in terms of, all of these kinds of things. What does the BedZ development consume? And it's, in most cases, 50% of the amount that are in the others. And what could it consume if people change their behavior also to take advantage of the things that they have here? Worked on site, did other kinds of things like that, and in which another 25% of all of those costs will go down. And so one is just simply showing that there are financial advantages to people occupying units and people operating units, etc. Another is to get the pricing right on the public side so that there are real incentives for people to do these kinds of things. I think both could make a difference.
Susan. One more, okay.
Yeah,
One last question.
Do you see any political will to allow that to happen?
Not at the national level, certainly in our communities. I mean, Portland, made that possible, that development of treating the wastewater in the street. I mean, so there are some places which are making that possible.
I thought
Yeah.
of something. Most of your examples were successful developments on kind of a neighborhood scale or district scale, which there's probably a reason why that certain scale is effective at creating sustainable development. But your opening statement was about plugging into public systems, and cities are going to continue to grow. People are going to continue to go to cities because, you know, it provides them opportunity for their lifestyle, etc. So how do you reconcile, I don't know if you could just comment on, how do we reconcile these two facts, that on the one hand, containing the scale of successful developments, like you pointed at this photograph, you know, if districts could be segmented, that could help them become more sustainable or their infrastructure more effective on the one hand, but on the other hand, cities are going to continue to grow.
Well, cities will continue to grow, and actually one way that they can grow without having to redo all of the large public systems is to make sure that individual pieces that aren't adding to the public systems, the sewer system, the water system, et cetera, on it. And so it is true, as Carol asked in her question, you know, that more opportunities are open when you get larger in scale. But, you know, that 4-block development, actually, it's really actually 1-block development with a street going down the center of it. In Portland, it's a pretty small scale, and they're doing a very ambitious thing in that area. And somehow that sewer system is not having to take care of all of those wastewaters from those 4 buildings that are on that site. So what I guess I'm saying is at each scale there are some opportunities. They get larger as you get larger in scale.
So all of your examples are predicated on a government or a system of infrastructure that can be rationalized and ordered. Is there a way that site planning can be brought to informal communities, or, you know, expanding slum areas that could rationalize on a local level and to improve the lives of people simply by bringing a kind of order and low-tech solution?
Well, I do talk some about that in the book. There have certainly been some very good projects in Colombia and in other South American countries where they have gone back in and installed modest infrastructure into the informal communities, made the quality of life infinitely better in those communities, and aided in people's ability to get up and down the hillsides and other such things. And in many cases, actually, those have also involved creating a common trenches for things that allow you to install and maintain and repair them without having to disrupt the entire community, because you know, the hillside is very hard to get to those areas to work on those kinds of things. And things like funiculars and cable cars and other kinds of things, I think, are, you know, much neglected technologies that for those areas, but also for other areas. I have a colleague in Los Angeles who is working on creating a cable car system that will take people from downtown to Dodger Stadium, you know. It sounds like a very interesting idea, actually, to use that kind of a technology for the, you know, the single purpose rather than flooding the roads with cars and creating bigger parking lots and other kinds of things like that.
This is my last question.
Okay, thank you.
And that hopefully in general, and we usually think of as kind of a service to our many, oh, come on in, just starting, architects and engineers and other people who are members and supporters of the museum, because would you like to come a little bit closer instead of so far away? Thank you. But what the museum does for people who are new here tonight is to look principally contemplate from the point of view of architecture and urban history at what is the history of the skyscraper, the history of New York, and our lecture series does that as well. And we want to approach these topics by understanding what it is that the different professions do. How do architects work with engineers? How does development and construction affect the way that buildings take shape and the way that the city takes shape? And if you have a time to look around afterwards at this particular exhibition, which is called Skyline, and if you just beelined it up the stairs, you didn't enter the exhibition properly, you should come up through the introduction over on the ramp. Because for this show in particular, we wanted to take the span of the history of the skyline of New York, which begins in 1874 with our first tall buildings, the elevator-served office buildings that made possible the vertical rise of the city, and to look at that span of the vertical rise of the city and its spread across the island in periods that were meaningful. And so in order to do that, and we divided it up into 5 periods, and that's what you can see and read through the exhibition, we wanted to look at economic, technological, and regulatory forces that shape buildings. So I hope we'll have a chance to do that and to think about the skyline and explore it through the exhibition and come back because in the lecture series that we do, we focus on issues of urban history, but also practitioners that talk about what they do and what are the decisions that they make and how does design happen. So tonight we have a practitioner whose book and lifetime of work we're celebrating in the title of this, I say new book, but it's a version of a book that he's been writing since his first years as an architect and planner, when he began to teach at MIT and was a colleague of Kevin Lynch, who wrote the first famous textbook called Site Planning. And Gary Hack, in his decades of teaching at MIT and at University of Pennsylvania, has filled this tome, this heavy tome, with projects that he's worked on, as well as parts of the city and the world and countries that he's analyzed. So I'm very pleased to be able to call Gary and Lynn good friends, and we have had many discussions about architecture and urban development, and every time we have one of those, it always turns out that Gary has been the planner of something that we're talking about. His experience is deep in New York, and as evidence of that, he helped to plan Rockefeller Park here in Battery Park City, as well as West Street, and then a number of blocks in between the traffic lights. If you want to know why West Street looks the way it does, ask Gary, because it was his firm that was involved in making those decisions. It turned out, as we were thinking about how we were going to reorganize the south wall of our gallery, which needs to be refreshed, and we'll tell the story of the redevelopment of Ground Zero and the rebuilding of the World Trade Center site. I had not realized until I looked at the photo credits that Gary was on the team of the master planning with Leapskin Studio, who won the competition for the site development. So just taking that small local area here of Lower Manhattan, Gary's put his hand and his brain on so many different parts, but he also has worked around the world. Well, as you mentioned, teaching at both MIT and at University of Pennsylvania, where at MIT, headed the Department of Urban Design and Planning, and at University of Pennsylvania, he was the Dean of the School of Architecture. So he has been lots of places around the world in addition to the US, and has taught at universities, most recently in China and to many other places in Asia, but many cities in China. And then around the world, in the last few years, he's been part of a Coursera course that in urban design and history of cities, and it was kind of the broad title that with colleagues from the University of Pennsylvania has about 70,000 subscribers and counting in that course. So it's a great pleasure to introduce Barry Hackett to be in this intimate situation for this evening, where he'll give a talk about how site planning has been not invented, but re-presented, I suppose, as sustainable site planning, which is the talk for tonight. And then we'll have the opportunity to ask questions and have a conversation after.